In this video, let us try adding 1 by root 2 plus 1 by square root of 3. We see that both of them are irrational numbers and the irrational component being in the denominator. So how do we go about adding these two numbers? So in order to do this, let me compare this with our normal addition of rational numbers, half plus 1 by 3. What do? We just find the LCM of the denominators 2 and 3. In order to find that, we write down the tables or the multiples of 2. What are the multiples of 2? 2, 4, 6, 8 and so on. And the multiples of 3, 3, 6, 9 and so on. And now we have spotted the least common multiple. The lowest multiple which is common to both 2 and 3 is 6. So 6 is the LCM of 2 and 3. So what do? We try to make the denominator into 6. So for multiplying half by 3 by 3 and multiplying 1 by 3 by 2 by 2 will do us the necessary trick, isn't it? Now we will be ready to add both of them. So how do we do similarly? How do we find the multiples, the LCM of root 2 and root 3? Is it possible? Let's explore. So what are the multiples of root 2? If I multiply root 2 into 1 is root 2. Root 2 into 2, 2 root 2. 3 root 2. So these are the multiples of root 2. Similarly, if you go about multiplying root 3 by every integer 1, 2, 3, 4, you get root 3, 2 root 3, 3 root 3, 4 root 3. There seems to be no end to it, and we seem to have not arrived at any common multiple. Let's check it out. Suppose, of course, if you are convinced here that there is no LCM for square root of 2 and square root of 3, you just go ahead. But if you're still not convinced, if you still need an explanation, let us assume there is one multiple m root 2, m times root 2 is equal to n times root 3. Let us assume that there is some common multiple, and let's represent the multiple by m square root of 2 and n times square root of 3. So what does this mean? That is, if there is a common multiple for these two irrational numbers, what does it mean? It means that m divided by n is equal to root 3 by root 2, isn't it? Or what is root 3 by root 2 actually? You can write it as the square root of 3 by 2. Now we know that root 3 is an irrational number, root 2 is an irrational number. Here in this case, the square root of 3 by 2 is also an irrational number, because this 3 by 2, this 3 by 2 which is inside the square root is an imperfect square. So this is also an irrational number. So by saying that there is a common multiple for root 2 and root 3, we are contradicting the fact that the square root of 3 by 2 is irrational, because we are writing it as m by n, the ratio of two integers. This is a clear contradiction, isn't it? So there cannot be, this is not possible, there cannot be any m times root 2 which is equal to n times root 3, or in simple language, there cannot be an LCM for square root of 2 and square root of 3. So this is why we rationalize the denominators. You would have heard of the term rationalizing. Of course, I will tell you what is it and how to go about it. But the reason for rationalizing, the purpose of my video is the reason for rationalizing the denominators in order to do an addition, to perform any operations, addition, subtraction, etc. in irrational numbers. So how do we go about rationalizing? Let us explore that. This is nothing huge. This is not, it's just a trick. It's rationalization of denominator is just a trick which we do in order to perform the addition. So let me consider the same problem now. 1 by square root of 2 plus 1 by square root of 3. Now how do we do the rationalization? What if I multiply 1 by square root of 2 by root 2 by root 2? I am not changing the value of this fraction. the value of this irrational number. At the same time, we are multiplying both the numerator and denominator by the same quantity, root of 2, and 1 by root 3 can be similarly multiplied by root 3 by root 3. Now this changes the whole fraction to root 2 by 2 root 2. Of course, it does not alter the value is still the same, root 3 by I'm sorry, I'm going wrong. This is not the case. Of course, you would know by now. The purpose was rationalization of the denominator. So, root 2 into root 2 is 2, isn't it? Similarly, the denominator here, root 3 into root 3 is 3. The numerator may contain irrational numbers. That's no harm because we can still handle. We can handle irrational numbers in the numerator. So, now we just go ahead performing the addition of fractions 2, 1, 3. The LCM is 6 as we saw just now. So let's multiply this by 3 by 3 and the second fraction by 2 by 2. We get 3 root 2 by 6 plus 2 root 3 by 6. So we can write it as one single fraction as 3 root 2 plus 2 root 3 by 6. We have simplified the initial problem which has been given to us. Now to understand further how to go about rationalizing, let me give you a few more examples so that you are clear with this trick. Let's consider this example, 1 by root 7 minus 2. Now clearly the denominator contains an irrational number. How to get rid of it or how to rationalize it? Just try. What if we multiply both numerator and denominator by the term which is already in the denominator, root 7 minus 2. So do you think that the denominator will be rationalized by doing this? If you multiply and see, root 7 minus 2 is in the form a minus b into a minus b, which is a minus b the whole squared. If you apply the formula or even if you multiply directly, you will find that there is still an irrational component. You would not have fully rationalized it. So let us try multiplying by root 7 plus 2, root 7 plus 2. Remember, this is minus and this is plus. So now this is in the form a plus b into a minus b, which is a squared minus b squared, isn't it? So you get a is root 7. So root 7 the whole squared minus 2 squared. In this case, we have eliminated the irrational number which is in the denominator. So we will be getting a rational number which is root 7 the whole squared is 7 minus 2 squared is 4. So you get 3. 7 minus 4 is 3. So now we can proceed with the division. Yeah, of course, it's division. 1 by root 7 minus 2 can be, after multiplying by root 7 plus 2 and root 7 plus 2, both in the numerator and denominator, can be expressed as root 7 plus 2 divided by 3. So we have simplified it to an extent. There is no irrational number in the denominator and we have obtained root 7 plus 2 by 3. So I hope you are clear with rationalizing the denominator. Let me quickly do one more example so that you get complete clarity. Let us take for example 1 by root 5 1 by square root of 5 plus square root of 2. As we saw in the previous example, if you want to completely eliminate the irrational component in the denominator, let's multiply by root 5 minus root 2. So that it becomes of the form a square minus b square, and the root 5 term, the square root of 5 and square root of 2 are eliminated. So here the numerator also would be multiplied by root 5 minus root 2. So you get root 5 minus root 2 into root 5 plus root 2 is root 5 the whole squared minus root 2 the whole squared, which is equal to 5 minus 2, which is equal to 3. So we can represent the fraction which has been given to us for rationalization as root 5, the numerator of course becomes irrational, root 5 minus root 2 by 3. So I hope this is clear to you. We have learnt the trick of rationalization in this video. Thank you.